this is Britt Caswell with another example video. In today's video, I'm covering example 3 from section 7-3 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to use the unit circle to evaluate tangents. Alright, now I'm working with a key definition here in that the tangent of an angle is equal to the sine divided by the cosine. Now my students, they get to use open notes in this current year. I'm in the pandemic right now. So right now my students are getting to use the unit circle. Now if you guys don't get to use a unit circle, I'm gonna do these examples to where I'm drawing in the reference angles. But if you have one of these bad boys, that unit circle is bae, I tell you what. Alrighty, so now let's go ahead and let's do this. So to find a tangent, again, I'm going to find the sine and the cosine of the angle using special right triangles, and then I'm going to divide those and get my tangent. So negative 5 pi over 6. Alright, we know that a negative angle measurement is going to be down here in the bottom pi of the circle, right? Because we're going clockwise. So down here somewhere is my negative 5 pi over 6. So because it's divided into 6, that's what I'm going to be doing with my pie slice here, is I'm cutting it into 6 pieces. Now 1 pi is 180 degrees, so if I'm cutting it into 6 slices, each of these little slices here is 30 degrees, if that helps you to understand where I'm at with this, okay? Now I only want 5 out of those 6 slices, so we can go ahead and we can chow down on one of these slices. Num, 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 num. Oh, and it's going to get rid of my nice little lines there. Alright, so there we are. There's our 5 pi over 6. So this is also negative 150 degrees, right? That's going to help us out eventually. So if I draw my initial side here on the positive x-axis and my terminal side, there it is. And so the reference angle I'm actually using is a special right triangle from the wedge that we ate. Right? Because that wedge looks like this and it's 30 degrees. So that means this is a 30, 60, 90 right triangle. 30, 60, 90s are really nice because they follow this pattern of x, 2x, and x root 3. Alrighty, so this is on a unit circle, so I know that the hypotenuse of this triangle is 1, because that's what a unit circle means, and it's a radius. So if my hypotenuse is 1, my short leg is half of that, because the hypotenuse is twice the short leg. So my short leg here is 1/2. And then to get my long leg, I take that short leg and multiply it times the square root of 3. So 1/2 times the square root of 3 is root 3 over 2. Now the other thing is I have to think about my sines. Alright, think about the direction that this point is going to be at, right? Because here's my x, y that I want. So it is going backwards on the x-axis, so it's going to be a negative root 3 over 2. And it's going down on the y-axis, so it's a negative 1/2. So now that I have that, now I can go ahead and find my tangent. So my tangent of this angle is my sine, which is my y value, divided by my cosine, which is my x value. Whew, that's a little ugly, isn't it? So what I'm going to do is I'm going to use that keep change flip to divide those fractions. Okay, so I'm going to keep the negative 1/2, change this division to multiplication, and then flip this one to look like negative 2 over root 3. So you can see here my 2's cancel out and my negatives will cancel. So I have 1 over root 3, which is kind of yucky, right? We don't like a radical in the bottom. So I'm going to multiply this by the number 1 to get that radical out of the denominator, and we should be good with our final value. Alright, so I'm multiplying by root 3 over root 3 because that equals 1. So my tangent, I'm going to write my final answer out because, that's a lot of math. So my tangent of negative 5 pi over 6 is root 3 over 3. And this calculation was ugly. They aren't all ugly. It just happens to be that way this time. I mean, yeah. Alrighty, so the tangent of 3 pi. First we need to figure out where the heck 3 pi is, am I right? So remember, 1/2 of the unit circle is pi. So here's 1 pi, here's 2 pi, here's 3 pi. So the tangent of 3 pi is the same thing as the tangent of pi. Okay, so if we can find that tangent, we are good to go. Alrighty, now at pi, that ordered pair is negative 1, 0. Okay, so the tangent again is the sine divided by the cosine. So my sine here is 0, and my cosine is negative 1. So the tangent of 3 pi is 0 divided by negative 1, which is 0. It's a lot less ugly than you'd think it is, huh? Alrighty, let's try this one. So now we're looking at negative 3 pi over 2. So it's worth noting that pi over 2 is the same thing as 90 degrees, right? Because here's pi, here's 0, so pi over 2 is half of a pi, which is 90 degrees. So if I'm doing negative 3 pi over 2, what I'm doing is I'm going backwards 90 degrees 3 times, because I'm calling this negative 3 times pi over 2 like that. It's negative 3 times 90. Hopefully that'll help you to see it a little bit. So here's negative pi over 2. Here's negative 2 pi over 2, or negative pi. And here is negative 3 pi over 2. So the angle that I'm referencing is actually 90 degrees. And that's a whole lot less scary than we thought, isn't it? So I'm just drawing in my initial side and terminal side so we can see them a little better. Now the ordered pair here at 90 degrees is 0, 1. So when I go to find my tangent of negative 3 pi over 2, my sine is my y value, which is 1, and my cosine is my x value, which is 0. So my sine divided by cosine is 1 divided by 0, and that's not allowed. So what we say here is that this is undefined. When we get into the tangent section, which I think is 7.4, I don't remember off the top of my head, you'll find that you'll have an asymptote there, which is kind of cool. Alrighty. So now part B is dealing with 675 degrees. So that's more than a circle. So what I'm doing is I'm taking that 675 degrees and subtracting 360 from it. Alright, so this is the same thing as 315 degrees. So what that'll do is that will put my reference angle down here. 315 degrees. Now that means that this reference angle right here would be 45 degrees, which I know. So I'm going to actually draw in a 45, 45, 90 to help me to describe that angle. Okay. Let's pretend I know how to draw. 45, 45, and 90. So with the 45, 45, 90, you know that it follows the pattern of x, x, and x root 2. Alright, now just from experience with this, remember on the unit circle, anytime you have the 45s, those 45s give you root 2 over 2. Alright, so I know that these are just root 2 over 2 just from my experience with the unit circle. I can go through and do the calculations if I want to, but I'm lazy, so I'm not going to. Now let's talk about their signs. So this is on the positive, right? We're looking at this ordered pair here. So this is on the positive x-axis, so that's positive root 2 over 2 for my cosine. But it's going down on my y-axis, so it's negative root 2 over 2 for my sine. So those are pretty important when we go to do our calculations. So my tangent of 675 degrees is equal to the sine, which is negative root 2 over 2, divided by my cosine, which is positive root 2 over 2. Now right now you guys are probably thinking, keep, change, flip it. I mean, you don't have to. Root 2 over 2 and root 2 over 2, you're dividing a number by itself. And so you know that that is 1 when you divide a number by itself. Now, 1 is negative and 1 is positive, so this is going to be a negative 1. But there you have it, guys. So that is how to use the unit circle to evaluate tangents. Until next time.